We'll proceed in pseudo multivariate calculus. Amazing and mind-blowing discussion that we are making on the pseudo multivariate calculus. Pseudo multivariate calculus means can we do normal, can we do, can we solve a mathematical problem the way any 5th standard, 4th standard, 3rd standard student does? Okay, not like a PhD. Okay, there is a way to solve a problem like a PhD. Means you start using vector and then you start using lot of summation and then high class approximation and then delta x, delta y tends to 0. And then if you see this distribution and that distribution and then so many. Okay, the concept is that can we solve a mathematical problem through the way any student does. Okay, that arena, what we are bringing now, that is typically it is known as pseudo multivariate calculus. Means we are doing pseudo multivariate calculus where we will solve something that is looks very simple. Okay, in that way, we are in phase of calculating the volume. We have already calculated the surface area and surface area of a sphere. We have calculated through the Cartesian coordinate system. We have calculated through the spherical coordinate system, and we have calculated through the spherical and Cartesian coordinate system hybrid model. So in every fashion, we have calculated the surface area of a sphere. Okay, can we calculate the volume of a sphere? That is the new concept that we are bringing in. What is volume? What is surface area? If I say surface area of this, then anyone would say, I don't know. What is surface area of this sphere? Then anyone would say, I really don't know. I have no knowledge that how I can calculate surface area of this sphere. Not possible. Okay. Can you calculate surface area of this rectangle? Yes, certainly. Because it has two sides, one is width and one is length, and multiplication of width and length gives the surface area. Okay, from there only we proceeded and finally we end up in calculating the surface area of a sphere, and that is 4 pi a square. Okay, now similar question anyone would ask, can we calculate the volume of a sphere? Can we calculate the volume of a sphere? That is the question. Can we calculate volume of a sphere? Okay, I don't know. What is volume of a sphere? Okay, if I give someone a cuboid, if I give someone a cuboid, okay, this is typically a cuboid. How nice, elegant it is, I don't know. But certainly this is a cuboid. This, this is a cuboid. What is the volume of this cuboid? Now anyone would jump. I know. What is the volume of this cuboid? That is height into area. This is the volume of a cuboid. Height into area or height into top area. Whatever comes to mind. Height into base area or height into top area. Whatever. Same thing, right? That will give the volume of a 3D shape. Okay, if I ask, can you calculate volume of this? Can you calculate volume of this? Then where is the surface, where is the height and those kind of things. Okay, if I say I'll give you the surface area vector I'll give you. Okay, now in that sense, can you calculate? Okay, then surface into height is the volume. Surface area vector, surface area vector. Okay, surface area vector is the vector direction of the surface area vector is perpendicular to the surface. Anyone should mind it. It is not the typical line vector. Line vector is the vector that is along the line. What is the line vector equation of this line? This is a line. It can be y equal to x or y equal to 4x, whatever it is. This is the equation of a line. Now, any vector, if I if I try to represent this line as a vector, then a vector will be along the line. Okay, this is vector representation of a line, and a vector will be along the line. Okay, in that sense, what is the area vector? Then area vector will be perpendicular to the surface, not along the surface. If this is the surface, then area vector will not be along the surface. It will be perpendicular to the surface. That is the difference. Anyway, if I consider I'm trying to calculate the volume of this cuboid. I'm trying to calculate volume of this cuboid. In that sense, if I get area vector, then I have to multiply it with the height. Okay, let's start. What is the volume of a 3D shape? Area into height, or height into area, is the volume of a 3D shape, of a cuboid. This is the simplest of the 3D case. Mind it, whenever we do multiplication, we make sure that multiplication will happen only for the two items. This is the catch here. I'm not saying height into width into length is the volume. Height into base area, height into the top area, whatever it is. Multiplication of only two items. That is the catch in a pseudo mathematics. So width into length is the area. Height into area is the volume. Now, in that sense, what is the area vector? Consider area vector is A vector, or magnitude of A, and then A unit vector. That is the area vector. How I can multiply two vectors? I have to multiply these two vectors to get the volume, right? Or someone can say volume vector. Okay, in vector term, I'm sorry, the actual volume what we did is height into area. Height into area is the height into area is the net volume. Okay, height, if we see, what is the height? Consider this in xy plane, and if I take this is the height, this line, up. Okay, this line is the height. This line is the height. If this is origin and this point is x comma y comma z, then the height is x square plus y square plus z square root. If it is origin and this point is x comma y comma z, then this height is x square plus y square plus z square root. This is same as the vector representation of this height line, magnitude of it. I believe it is all right. So in that sense, I can say height vector, height vector into area vector. If I'm making, please mind it that slowly we are converting a line, length of the line into a vector form. This is pseudo multivariate variable calculus. Pseudo means we start in an abstract fashion. Height into area is the volume. Height can be described as or as along a line distance between two points. If it is one point is origin and other point is x comma y comma z, then this height is x square plus y square plus z square root. That is same, and then into area into the area. Now height is from origin to x comma y comma z. If height is from origin to x comma y comma z, then distance is x square plus y square plus z square root. So square root of x square plus y square plus z square, or if this is origin and the height point is x1 y1 z1, then square root of x1 square plus y1 square plus z1 square root into area is the net volume. Now, this square root, what we have said now in Cartesian coordinate system, it is as good as magnitude of a vector that is connecting the origin point and x. Why we are bringing into vector? Because at the end we have to compute the volume of a sphere where direction matters. Okay, not everything is 90 degree to each other. So now x square plus y square plus z square x1 square plus y1 square plus z1 square root. This length will be a length of a vector that is connecting origin and point x1, y1, z1. In that sense, it becomes x1 square plus y1 square plus z1 square root. That is magnitude of a vector, that is xi plus yj plus zk, or x1i plus y1j plus z1k. Now, if I have now in the vector notation, if I say, then magnitude of a height vector, that is, if I say height vector is z vector, if height is k axis, and area is on xy plane, area is on xy plane, then it is zk vector, zk vector, okay, or if I say zk vector, then magnitude of zk vector into on the xy plane, whatever we have area vector, magnitude of it. Makes sense? Height into area is the net volume. Height is nothing but the magnitude of the height vector, that is zk magnitude, into magnitude of area vector. Okay, I converted the area into area vector magnitude. Now, if I have two vectors, then I can calculate these two magnitude and calculate the multiplication. But it is only good if it is they are 90 degree to each other, not necessarily that they always be 90 degree to each other. In that sense, we have to take vector multiplication and whatever comes, that magnitude. Now, if I consider height vector as zk and area vector is a vector, then it becomes zk cross product or dot product. Okay. Now we know very well that if area is in xy plane, area vector will be in z along the k axis. If this is x axis, this is y axis, then this is the k axis. X axis, y axis, that is xy plane, and then k axis. If I have area on xy plane, then area vector will be perpendicular to the surface area, that is k vector. Now I have height also in k vector. I cannot take cross product. The way we calculated the area, that is width vector cross product of the length vector, give the area. But I cannot say area vector cross product of the height vector will give the volume, because they are in the same direction, knowingly, unknowingly. So calculating the multiplication through cross product will turn into zero, dot product. This is also called triple scalar product. Area is cross product and then one dot product. Anyway, zk vector dot product with the area vector, whatever comes, magnitude of it will be the net volume. Where from we started, where we have landed. Okay, thank you very much. Can you calculate it? Okay, zk vector dot product with the area vector. Let's start with the Cartesian coordinate system. If I see Cartesian coordinate system, then area vector in Cartesian coordinate system is minus dz by dxi minus dz by dyj plus k bracket close dx dy. If people remember it very well. If people do not remember it very well, then area vector is calculated by cross product of length vector and width vector. If length vector is a vector and width vector is b vector and height vector is z vector, then it is z dot in bracket a cross b. That is the area vector. Okay, a vector is along x-axis and b vector is along y-axis. Z vector is along k-axis. Now let's break it. A vector, how I can take a vector? Now consider this is origin and this is x-axis. This is origin and this is y-axis. This is origin, this is z axis, but z will go this side though. Anyway, consider this side. Or it's not digestible. Hop, hop, hop. This is origin, then this is x-axis. This is origin, then this is y-axis. If this is origin, then this is z-axis. Okay, if that is the scenario, if that is the scenario, then I am taking a vector along this, b vector along this, and z vector along this. Now a vector, if I take any point here, x comma y comma x1 y1 z1, and then here I take x2 y2 z2, and here I take x3 y3 z3, then the net volume is a vector cross b vector, whatever comes, dot product with the height vector. It will come as x1i plus y1j plus z1k cross product with x2i plus y2j plus z2k. Whatever comes, this cross product will give a new vector. Whatever comes, okay, dot product with the height vector, that is x3i plus y3j plus z3k. But anyway, since it is along the k direction we have taken, x3 and y3 is gone. And here we have taken along x-axis, y1 and z1 is gone. Here, the x1, x2 and z2 is gone. Okay, whatever it is. Now anyway, this is the generic code of writing the volume vector. A cross B, that is the area vector, dot product with the height vector. Area vector, if we are trying to calculate, then one is xi plus yj plus zk. If I talk only in xyz. Another is again, that is B vector, is xi plus yj plus zk. Cross product, dot product with again xi plus yj plus zk. Now first xi plus yj plus zk, a vector is along x-axis. I'll take out x from it because now these are the straight line. If I talk about x1 y1 z1, x2 y2 z2, x3 y3 z3, if I'm trying to calculate surface area from vector A and vector B, then they are a straight line vector, that is x1i plus y1j plus z1k, and B vector is x2i plus y2j plus z2k. But if I'm trying to calculate surface area of a curved surface, then this A1 vector becomes a curve vector, and B vector, A vector becomes a curve vector, and B vector becomes a curve vector. But as per the pseudo mathematics, we are not going to change whatever we have written. So we have written A cross B dot product with the height z vector is the volume. A vector was here earlier, it was a straight line vector, that is xi plus yj plus zk. B vector was a straight line vector, xi plus yj plus zk, or x1i plus y1j plus z1k cross product with x2i plus y2j plus z2k dot product with x3i plus y3j plus z3k. These are the straight lines. If I take a vector as a curved line, then I have to take out one independent variable. This is what we have seen in the past video. That is called curved line vector. What is curved line vector? Is whatever the straight line vector we have to represent this straight line vector in y by x and z by x form. Then it will become a curved line vector. Okay, in that sense, from A I'll take out x, and from B I'll take out y. Then it becomes I plus y by x j plus z by x k bracket into x cross product with y I plus j plus z by y k bracket y. Cross product of these two will give the area vector. If I replace division by differentiation, this is how, see how we are proceeding. I have to replace division by differentiation because differentiation is same as division only. And then I have to replace multiplication by integration. If that is the case, then it first one becomes I plus dy by dxj plus dz by dxk bracket close dx cross product with dx by dy I plus j plus dz by dyk bracket close into dy. Now, In Cartesian coordinate system, if we take three dimension, then xy plane is considered as independent and height is considered as dependent. In that way, x-axis and y-axis, they are independent to each other. So dy by dx will be 0, dx by dy will be 0. In that sense, we have I plus dz by dxk, bracket close, dx cross product with j plus dz by dyk, bracket close, into dy. This will be the area vector. If someone solves it, then area vector becomes minus dz by dxi minus dz by dyj plus k. This is the area vector. Minus dz by di minus dz by dxi minus dz by dyj plus k, bracket close, dx dy. This is area vector. Okay, this area vector I have to do. What is your area vector? That is minus dz by dxi minus dz by dyj plus k, bracket close, dx dy. This full is area vector that I have to do dot product with the height vector. Okay, height vector is zk. Xy will go away because we have taken a vertical line in the height vector. Okay, in that sense, what is height vector? Okay, if I'm trying to calculate the volume of this sphere, if I'm trying to calculate volume of this sphere, then this surface is all right. Surface area vector is different at different point. This is surface area vector at different point. That is minus dz by dxi minus dz by dyj plus k, bracket close, dx dy. Okay, where y and x are independent components and z is dependent component. Okay, that is all right. But z, what we have taken, that is a straight line. Anyone can take z as xi plus yj plus zk. Okay, in that case, if I take height vector as xi plus yj plus zk, okay, in that sense, if I take like that, then I can take out z, because for the height z is the main thing. Z is independent component for the, if I consider only the height. In that sense, it becomes x by zi plus y by zj plus k into z, or dx by dzi plus dy by dzj plus k, bracket close, into dz. Okay, dx by dz is 0, because if I take a completely vertical, then with the z is varying, x is not varying. When z is varying, then y is not varying, because exactly it is vertical. Okay, in that sense, dx by dz is 0, dy by dz is 0. It becomes k vector dz. Okay, dzk vector. Now I have to do dot product with dzk vector, dot product with minus dz by dxi minus dz by dyj plus k bracket close, dx dy. Okay, in that sense, I and j will go away because dot product of k and k will only remain. What is the volume? Volume is dx dy dz and integration over the volume level. That is, z is from one layer to another layer, y is from one level to another level, and x is from one level to another level. Someone can try. Amazingly mind blowing. Anyone would say you could have tried dx, dy, dz in Cartesian coordinate system, and then z is from 1 to 1, z. Okay, it's not that simple. Anyway, now through the way we started, it came to this level only. Someone would say that you took z dot area vector. You took area vector as a surface vector. You could have taken area vector as xy plane also. Area vector at xy plane also. What is area vector at xy plane? That is a question. Area vector at xy plane. Okay, if I'm trying to calculate the volume of this, if I'm trying to calculate volume of this, consider this is center at the origin, which xy plane will hit it at the center. Top hemisphere is above the xy plane and bottom hemisphere is below the xy plane. If I just calculate the volume of the top hemisphere, then volume is nothing but surface area into height. Right now we have taken surface area as the sphere surface area into the height. I can take this surface area into height also. That is also a volume. This surface area if I take, then it is dx dy into height, or width vector, length vector cross product. Width vector is xi because y and z are 0. This length vector is yj because x and z are 0. Xi cross yj, that will come as xi cross product yj. If I take xi, or rather if I, the way we did, it is xi plus yj plus zk, cross product xi plus yj plus zk. Now here if I take out x, then it becomes I plus dy by dxj plus dz by dxk into dx. Okay, division directly I have taken a differentiation. Okay, cross product with same thing. There I am taking y out. Dx by dy I plus j plus dz by dyk into dy. Now, in the first term, which is x-axis, here dy by dx and dz by dx will be 0 because they do not vary with the x-axis. It is exactly along x-axis. In that sense, it will only become dxi and there it will become dyj. Dxi cross dyj will be dx dyk vector. And here the height vector what we are taking, it is again xi plus yj plus zk. Here z is variable. If you see, z is variable. If I take height vector, then only z is variable. But so I'll take out independent variable z here. Then it becomes dx by dzi plus dy by dzj plus k bracket close into dz. Dx by dz is 0. Dy by dz is 0. It becomes dzk. At the end become dzk dot product with the dx dy k. That will become dx dy dz only. Or we tried with the nice way, that is area vector, that is area vector of the area vector we took rather than xy plane as area vector, we took this as area vector, that is minus dz by dxi minus dz by dyj plus k dx dy, or we can directly take dx dyk. Same thing came as dz dx dy dz and then integration in the volume level. Amazing, mind blowing. Now, if someone can try it, what is z? If I see z, if I try to see full, then z is minus a square root of a square minus x square minus y square. To z is, that is full. If I take top hemisphere only, then z is 0 to square root of a square minus x square minus y square, because x square plus y square plus z square equal to a square is the formula for the sphere. Okay, why? If I see this sphere centered at the origin, if I see the xy plane, there will be a circle. If it is a circle, y is minus square root of a square minus x square to square root of a square minus x square. X is minus a to a. If someone does this integration, then for top hemisphere only I am calculating, then dz will become z, and z is square root of a square minus x square minus y square. Dx dy. Y is minus square root of a square minus x square to square root of a square minus x square. X is from minus a to a. Calculate it, then volume will be 2 by 3 pi a cube. Okay, we'll try calculating in the next session. Okay, now concept is appearing. Is it the same thing that we will see in the spherical coordinate system? What is your spherical coordinate system? Please watch our previous video. In a spherical coordinate system, area vector. This area vector is r square sine phi d theta d phi. R square sine phi d theta d phi r unit vector. That is the area vector, where phi is angle from the vertical, and phi is angle from the vertical, theta is angle on the xy plane, and r is the radius, that is center of the sphere. It goes outward. R square sine phi d phi d theta r unit vector. Okay, that is the r unit, r square sine phi d theta d phi r unit vector. This is called area vector. Area vector dot product with the height vector is the volume. What is the height vector? Height vector, I mean, if I want to calculate the area, then I have to calculate the magnitude of the area vector and go with the integration. What is magnitude of area vector? R square sine phi d theta d phi r unit vector. R unit vector will go away, and r square is a constant, it will come out. Sine phi d theta d phi, phi 0 to pi and theta 0 to 2 pi will give the surface area. What is the volume? Surface area into height is the volume. If it is in a spherical coordinate system and this is the surface area, then height means its third coordinate. Third coordinate is r vector. R vector from center of it is piercing the surface and it is going like this, that is the R vector. Okay, then R vector, R vector, R vector. Okay, now if people remember it, what is the position vector in a spherical coordinate system we had taken? If I take R vector right now, I have just took as R vector. If I take R position vector, then it is R vector plus r sine phi theta vector plus r phi vector. This is the position vector in a spherical coordinate system. It is similar to xi plus yj plus zk. It is similar to that. That is r vector plus r sine phi theta vector plus r phi vector. Okay, if I take out r, because when we are talking about the height vector, that is along the r side, r is independent here. If I take out r, it becomes r unit vector plus sine phi theta. Okay, sine phi, I'm sorry, it will become d of r sine phi theta by dr. Okay, more or less it will become d theta by dr, and there next it will become d phi by dr. Phi, r and theta, they are independent to each other in a spherical coordinate system. In Cartesian coordinate system, z is dependent upon xy plane. But in a spherical coordinate system, r is independent of the theta and phi. In that sense, if I take out r, then it becomes r unit vector plus 0. R unit vector plus 0. R unit vector into r. This will make an integral calculus. What we had, if I take out r, means we have r unit vector plus r sine phi d theta by dr theta unit vector plus r d phi by dr phi unit vector. If I take out r, bracket close into r, division will become differentiation and multiplication will become integration. In that sense, it becomes r unit vector r sine phi d theta by dr theta unit vector or d phi by dr phi unit vector into dr. Anyway, d theta by dr is 0, d phi by dr is 0. It becomes r unit vector dr. So dr r unit vector dot product with the area vector, that is r square sine phi d phi d theta r unit vector. These two r unit vector dot product will take away the r unit vector. It becomes r square sine phi d theta d phi dr, and r is from 0 to a, that is the integration for the r, and theta is from 0 to 2 pi and phi is from 0 to pi. Can someone believe this? That if I want to calculate the surface area of a sphere, calculating the integration of r square sine phi d theta d phi gives the surface area, and r square sine phi, just I add dr there, it will give the volume. But this is how it is. Okay, this is called mind blowing pseudo multivariate calculus. Just multiply height with the area, you get the volume. If your volume is r square sine phi d theta d phi, just multiply with the dr r unit vector dot product, you will get the volume. Okay, let's try r square sine phi d theta d phi dr. Okay, we will settle down r only. R is variable now. Okay, r square become r to the power 3 by 3, 0 to a to the power 3 by 3, that I can keep outside. A to the power 3 by 3 I can keep outside. Pi is 0 to pi, that will be pi. Pi a to the power 3 by 3. And then theta. Okay, theta, I'm sorry. Okay, I'm sorry. R square sine phi dr d theta d phi. R square dr become r to the power 3 by 3. R is 0 to a to the power 3 by 3, that I'm keeping outside. Sine phi d phi is minus cos phi, that is 0 to pi, that will become 2. 2 I'll keep outside. 2 a to the power 3 by 3. D theta is theta 0 to 2 pi. 4 pi a to the power 3 by 3, a to the power 3 by 3 is the volume of a sphere. Okay, we will work more on it, and Cartesian and spherical coordinate system hybrid, that also we will see, where x equal to r sine phi cos theta, y equal to r sine phi sine theta, and z equal to r sine phi sine theta. Then we will see more on it. Okay, if we do churning from every point of view, we are not getting the solution only. We are getting solution for the future problems. Of bigger problem, they sit on top of simple problem only. The way we started multivariable calculus, the bigger surface area or bigger volume, it starts from height into area only. That's it. And then slowly we turn into array, into a vector, height into area converted into height vector dot product with the area vector, and then slowly we got the solution. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 94831610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.